cover today. If you are new to large language models, we will introduce it briefly. So they are models because they receive an input and they are expected to return an output, and they normally learn from data. It's a language model because they receive as input words and they return as output also words. So if you played already around with ChatGPT, this is what you get, right? You chat through text. And then they are large because they are really big. These models have a lot of parameters. If you think about of it like a big brain, the parameters can be imagined as neurons, and the more neurons this model has, the more knowledge it can accommodate. And of course, like our brain needs a lot of energy, also these models need massive computing power to be trained on. So when we started to think how we can keep up and try to use this technology in our context, it was very clear there was a lot of hype, but also a lot of risks. In our context, for sure, confidential data upload is a risk. So we cannot allow this to be used within the company, because then the employees are uploading confidential data, like it happened for some companies like Samsung and Amazon. And we also noticed that companies like OpenAI started to create subscriptions, paid subscription, which means that only the few of those that can pay this service will have the opportunity to leverage this technology. And this was what made us think that maybe a good solution can be to have a private installation of such a model instead of relying in a product such as ChatGPT. And also we thought about looking into open source models. And this is how the idea of building our own GPT was born. And now if we go through, so if you remember the life cycle that I mentioned earlier, if we go through each step together, we can guide you through the adventure that it has been until now. So starting with the data. Normally the pipeline that you find in any kind of machine learning project is that you need to build a training set, an evaluation set, and a testing set. Normally the training and evaluation is where you teach your model how to perform a certain task. In the case of these large language models, what is happening is, because they are so big, expensive to train them. Normally big companies like OpenAI or Meta, they train these models because they have the resources, and then they make them available or not. So in the case of Meta, for instance, they made this model available. And this means that for companies like us, we are not a tech company, and also for individuals that want to try out, we can kind of skip this part of training, and we can directly grab the pre-trained models they make available, and we only need to think about the testing set. This testing set should reflect the task where you want to perform well. So as an example here, we bring the example where we would like to have our own internal GPT that is able to classify text, summarize text, generate text, and rewrite. So in terms of the daily tasks of our colleagues, we think this would already add value. And if you imagine a data set, it could be something as simple as having several CSV files. And for each CSV file, you can have different prompts. So each row is a prompt. As an example, for the classification, you can have a prompt that says, please classify this review of a customer as positive or negative, and you give the review. And now the question, if you remember the challenges that I presented earlier, the question is how to track this data. Because now I'm using 4 CSV files, but maybe in the future, for instance, Joana might use 8 CSV files and to expand this test data set. So how do we track these changes? Because if you evaluate with more data, probably the conclusions and the metrics will be different. We can use Git. There is the large file system of Git where you can also upload files. But when these data sets become huge, like thousands of files, this is not really a good solution. That's why we have some experience with DVC. So DVC is an open source tool. It means data version control, and it's basically a Git for data. So imagine that at a certain point in time, you have your version 1 of your data set with, for instance, 3 files, and then after 1 month, you have the version 2 of your data set. And now, how to make this map of the data, how to track this data. What DVC does is to create a cache, the DVC cache, and it maps each one of your files to a very small metadata file that is human readable. It basically points to the real data, but it's not the data, so it's much smaller. And then you can, it reflects, as you see here, the real data, and it can also track the changes. And then you commit to Git these very small files, which is much easier to manage if you are talking about a huge quantity of data. And this means that if you look at your Git repository and you have here, for instance, the main branch, then another branch, and 2 different commits, if you go to each commit, you will have a representation of your data set, a different one in each commit. And this section contains 1 hash, which is different for each time for each point in time. Also the size, because different files, different sizes, and the number of the files. In practice, this is really similar to Git. So when you do Git init, it will create your Git repo. In this case, if you do DVC init, it will initialize this cache. And then, just as you normally do Git add a certain file, you would do for files instead DVC add, and then you have here an example of one of our CSVs. When you do this command, what happens is this DVC cache is populated with this very small metadata file that I mentioned. And then you can finally use Git to add this small file instead of the original one, commit. Now you might ask, okay, now I understand that I have these small files which map my data set, but how can I access the real data? What we do is to create a remote place like for storage. We normally use S3 in AWS. So it means we create a bucket there. And once I do DVC push, all my data is pushed into there. And then if, for instance, Joana is in a different computer, in a different location, she can always do DVC pull, DVC checkout, just as in Git, but for data. So this is how we deal with the challenge of tracking data. And now I will pass to Joana for the fun part.
It's working, right? Okay, now that you know how to track your data set, we will see how to experiment with the data, but also with the models. So going to the machine learning part of our pipeline, Filipa mentioned that we have this use case for GPT, and actually we are loading some large language model from open source, from Hugging Face, and we did some preliminary tests, and now we are mainly working with Dolly and Vicuña. And you can see that Hugging Face has a lot of information about all of these open source LLMs. They also benchmark this with different criteria. And basically, Hugging Face also has this transformers package here, where you can import this pipeline, and it's very easy to load your model. So, for example, here we wanted to test Dolly, and it's basically just using this pipeline interface, and you need to pass the model path here, and then also define what is the precision of the model. Also, if you want to use custom code, and then once you have your model load from Hugging Face, you can start predicting with this model. For example, here we are calling this ask model and passing the prompt that was defined in the beginning. What is a meetup? You can also define what is the maximum number of tokens that will be retrieved from this model as an output. And then you can just print the generated text, which is the output of the model for this prompt. So you can do a lot of experiments with different models, different prompts, but at some point you will need to have a way of storing the models, but also the experiments that you are conducting with different models and different prompts. And for that, for experiment and model tracking, we are using MLFlow. MLFlow is an open source model and experiment tracking tool that was developed by Databricks. And basically, you have some examples here. For example, you need there is this local version of MLFlow where you can work in a standalone mode, but you can also share all of your experiments and models with your team. And for that, you need to create a remote tracking URL. Here, you need to define the path to the server version. You also need to define your own experiment. And in MLFlow, an experiment is this concept of a project. In this case, it's our GPT project. And then once you define this information, you can start loading your data from, for example, as Filipa explained, from DVC. We have an example here where we are parsing the information that is stored in the classification CSV. So basically, inside the CSV, you have all the prompts that you want to classify. So for example, you have a lot of sentences and you ask the LLM to classify each prompt as positive, negative, or neutral. Besides the data itself, you can also here define several architectures for this LLM. As you can see, it's also coming from the Hugging Face. It's basically the path to the model. And then once again, you are using this transformers package and instantiating this pipeline. So just passing the architecture path and some other information about that. And very recently, MLFlow had an integration with Hugging Face. So it's very easy for you to store your models directly from Hugging Face to the MLFlow platform. As you can see here, every time you want to start a run, and the run is kind of an experiment that you are conducting inside your own project, you just need to call this start run, and then in this example, to log the transformers, you just need to call this log model, and once again passing the model path. There is this also concept of MLFlow is tracking artifacts, which is like big files like models, weights, and so on. They also store parameters, tags, and metrics. Here, besides the model, you can also log a couple of parameters like kind of metadata from this model. In this case, what was the path from the model from Hugging Face, what was the parameter size, maximum number of tokens, and so on. In the MLFlow dashboard, you will see mainly this information. So inside the package Dolly that we just defined before, you can see all the information that was basically automatically logged by MLFlow. So as you noticed before, I didn't write anything about what is basically written inside of all of these files, but MLFlow automatically logged all of this information regarding your Python environment, your requirements, but also specific information about your model. And here you can see that MLFlow was also capable of inferring what was the transformers, let's say, ID, like what was the pipeline, the source model, and the task, but also what was the signature of this model in terms of inputs and outputs data structure. Another thing that MLFlow is also doing is pulling this model card from Hugging Face. So later on, if you want to see more information about the model that you are storing, like how this model was trained, in which kind of data, if there are other versions of this model, like for example, you have different versions of the model with different sizes, you can also store these model cards from Hugging Face in this case. So now you have the data, you also have a lot of models to test. And you can start then ingesting these prompts to your LLM in this case. Before I show you that you can start logging your model, and MLFlow has this concept of parent runs and child runs. So usually what I do is I create a parent run for one model, and then inside this parent run, I create several child runs for different prompts. So instead of logging all the time the model, I just log the model once inside the parent run, and then inside the child runs, I just log all the information about the prompt and the inference. And it's basically this code. So inside the first start run, you can create another start run that in this case is a nested run. And you can log all the parameters and metrics that are referring to an inference. In this case, for example, you can see that it's very easy to predict with this model. It's just the model, the transformers pipeline that we just created before, and then predict and pass this input, which is the prompt. In terms of parameters, we are storing the prompt itself, like the sentence that was inputted, but also the sentence that the model generated. We are storing these as parameters and as metrics, because sometimes metrics we associated more with like tracking the performance of this inference. In this case, we are logging the metric, the length of the input in terms of number of characters and number of tokens. The same for the output string, but also the inference time. And this is the information that you will see in the interface of MLFlow. So basically here you have the parent runs. This is like where the model is stored. This is the Vicuna, but you also have another parent run here where the Dolly model was stored. And then for each one of these models, you are testing, in this case, for prompts. So you can see that these prompts are the same. So one advantage of storing the experiments and using these tracking tools is that in the end, if you test a lot of models and a lot of prompts, you are able to compare them. You can see, for example, that for the same four prompts, usually Dolly has a lower inference time, but also it retrieves lower output in terms of number of characters. They also provide an interface to compare more automatically all of these experiments. But it's basically just a way of, in the end, define which is the model that you want to use and to deploy. So after this set of experiments with different models and different data, you start thinking about how can I make this application or this model available for others and for our users. And for that, we are basically serving our models with Gradio. Gradio is also a platform that we are using to create, in a fast and easy way, a web interface for this Conti GPT. You can see here that we are, once again, using the Hugging Face path for the Vicuña model, but you can also load these models directly from MLFlow. So MLFlow is a storage, model storage, and then besides only logging them, you can also load them directly from MLFlow, and then here in your web interface, you can log the model from MLFlow and then display all of this information. And basically, Gradio is just creating this front end where we have two inputs. So one is a text where you can write your prompt, your input prompt, and the other input is a drop-down with the different models if you have multiples, where the user can select which one to test. And in terms of output components, the interface is displaying the text, like the generated text from the prediction, and also a number, which is, in this case, the prediction time. Interface for Conti GPT. You can see the two components for the input, like the prompt, where you can ask, in this case, we asked to list the stages of building a tire, and then you can just select what is the model that you want to run with. Basically, then submit when you click submit, it will predict with this model, and then it will retrieve you the output here. And so basically this model was, as Filipa said, pre-trained with other data sets. But one thing that you can then also do is retrain this model with your own data. In this case, for example, we could have trained this model with Conti information about the building tire process, and probably this information will be more accurate. So now that you have your model, now that your model has an interface, a web interface, it's probably only available as a local host for you, and you'll start wondering, how can I industrialize my application and provide this to other users? And for that, we are using Pergola. Pergola is an application delivery platform. It was mainly developed to be used by data scientists, and it's the main point of interaction. I would say it's the web UI, where you can just click a bunch of buttons, and all the orchestration about the deployment of these models will be managed by Pergola. So the only couple of changes that you need to do in your project is to create a Docker file, but also you need to define this Pergola YAML. It's basically manifest where you define the requirements for your application, like in terms of memory and computation, and then Pergola will create an instance that fits your requirements for your project. One advantage of this platform is it's agnostic to the cloud provider, so they support Azure, Google Cloud Platform, and AWS. And here we also have an example on how to interact with Pergola. Basically, you need to start your build. You can see, for example, here the build was created. And then once you have your build, you can start your own release. So for example, you can have one for development, another for production, and so on. We are, in this case, creating one for QA. And once you have the release ready, you can also deploy it, and you will see then you will see exactly the same application that we have shown you before. It's kind of a new version, but yeah, it's basically very easy to use, and you don't need to care mainly about the operational and all the infrastructure, because everything is kind of managed by the platform. So just wrapping up all the tools that we presented today. So going back again to the data stage, starting with the data, there was this challenge of tracking the data, and for that we are using DVC, Data Version Control, kind of a Git for tracking data sets. We also address how to reproduce experiments with MLFlow, also how to store models within MLFlow platform. We also kind of explained that we are using Hugging Face to load all of these open source LLMs. And then again, to create a web interface for this model, we are using Gradio, and in terms of deployment, this Pergola platform. So we know that there are a lot of tools for data science and machine learning lifecycle. We decided to use these specific ones for the use case of Conti-GPT, also because in previous projects we were experimenting with them. But we know that there are a lot of, most of them are open source, besides Pergola, which is not open source platform. But we know that there are a lot of tools that one can use for all of these processes. And one of the reasons why we also bring this example of Conti-GPT today was to start this discussion. And I'm not sure if you are using other platforms, but if you are, we are very interested in knowing your feedback about them. We can also discuss other platforms that probably in our team we are using for other purposes. Just to give you contextualization, this ContiGPT, it was an internal initiative at Continental. I think it starts in the beginning of May this year, and it was roughly 4 people working in part-time, so almost one person for 1 month. And I think one of the things that really accelerated all of this process was all the experience that we had in previous MEL projects. In terms of future and roadmap for this ContiGPT, we are also aware of these inferencia instances from AWS. So they are probably more optimized to run inference for large models. But as of now, Pergola does not yet support these instances. We also would probably need to adapt our project to run with AWS Neuron SDK. And there is also other platforms that we explored in the past that we are deciding if we should also integrate with ContiGPT, like, for example, Valohai. It's not an open source platform, but one of the main advantages, at least from our point of view, is that Valohai answers most of these challenges that we are using with different tools. So Valohai also supports data version, experiment and model, storing, and deployment. And one of the advantages would be to have all of this tool stack in the same platform would probably facilitate all of our work. But if you have any other tools that you want to discuss today, I think we are very interested in hearing more about that. And just to finalize our presentation, we also asked ChatGPT to write a rep to encourage you guys to give us your feedback about your experience, your own experience with machine learning lifecycle, also these deployment tools and so on. So just be encouraged by the next slide.
Okay, thank you, Joana and Filipa. We are now open for questions. So if anyone has a question, please raise your hand and I'll bring the little mic to you and you can ask your question. Anyone? Okay, we got our first volunteer. There you go.
So in terms of the requisites to run this, how much resources do you need to run all of this training using? I saw that you were using Bcode with 13 billion parameters. That's one experience. How much RAM do you need, as an example?
Yeah, so as I said, all of this orchestration of the resources is done by Pergola. So I don't have the exact values, but it's mainly they instantiate an EC2 instance that is able to run Bcode. If it is 3 billion, probably we can also run it in our data lake. But if it is a model with more parameters, it's a higher instance, higher costs. But it's basically the cost that you have besides the license of the platform itself. It's the cost that you have during the uptime of the instance.
Yeah, I know that. I wanted to have an idea of how much it would
cost
take to, in terms of the specifics on the machine itself. How much it
So
would take.
right now we are in Pergola. We can use several cloud providers. We are using AWS.
Yeah.
It's running in a P3 2 times large instance. I think no, right? And for you to have a rough, so it's running the entire day and the entire night, let's say. We don't think it works. We are still now testing like how many people could access it in parallel. So this is a question that also, if you have some ideas, we would like to exchange there. For instance, Nono is working, that is sitting next right to you, how to do some stress tests to understand how many GPUs maybe, or how many instances in parallel we need. But if we run always the same instance, for instance, for 1 month, we think it will be around $3,000, which is already a lot. It's not even training. It's just to have one machine running and making it available the entire time.
Okay, thank you.
So maybe I can add to that, because we have been discussing a lot of this. So this week we saw, for instance, a blog post which compares what is worth it. Is it better to deploy your large language model, and maybe sometimes not anyone is, you don't have any user, or is it better to pay a license, for instance, to ChatGPT? I think there's no clear answer yet, but it pointed in the direction that if you will use it a lot, then it makes sense to have your own. And because we are a big company, we assume that this will be the right direction.
Anyone?
Thank you for your presentation. Can you hear me?
It's just
Yeah. I see. Yeah, I saw that you are using Hugging Face quite a lot, and as far as I understand, it's some predefined models. Can you please share your experience of optimizing usage of them, how you optimize the results of these models? Thank you.
We did a preliminary analysis of 2-3 models. The main conclusion was Dolly was like the lightest one, so it's easy, for instance, to run in your computer and to have so it's good for testing the entire setup. But Vicuña is definitely, like, at least from our experience, the best compromise between accuracy and time of inference. And what we did was to roughly compare what ChatGPT gives as an answer with what Vicuña gives, and it's actually pretty good. We didn't do, to be honest, any kind of tweaking. So some of us are researching a bit on how prompt engineering, for instance, can help us. So how you can design your question, your prompt to get a better response. But we didn't make any more research on our optimization. But if you did, we would like to know about it.
I think also one of the things that we are considering for the future is also to ask the user to give feedback about the response of the model, like with a like and dislike in the web interface, right? Mm-hmm. And then also have this, it's a kind of a proxy to try to analyze quality of the output of the model.
Okay.
As I understand, you're in the early stage of this experiments, right? So I'm curious about the business case. Like, who's going to be the user when it's in production? Like, is it end user, or it's going to be used within your company?
So most of the use cases that we are foreseeing is for internal use. Also, if we want to, so I can give you maybe some examples of internal use. For sure, customer complaint, for instance, if you want to very quickly filter your emails and say, okay, this is very critical, this is low priority, this is one of the use cases. The simplest use case, to be honest, is try that everyone that in our company is right now using ChatGPT, that they use ContiGPT instead. This would be already bring a lot of value. So the marketing team maybe asks ChatGPT for a nice LinkedIn post, or someone asks to write an email using ChatGPT. Also for coding, So it's not yet clear if GitHub Copilot would be an option, for instance. If it's not, we can use GPT to write documentation. In terms of external use cases, we have some products in the market, for instance, mobile apps, and we can customize the big risks. I think it's more dangerous. We need to be more cautious.
Any more questions? No? Okay, so I have one question. So I guess you are using this internally, or that's one of the goals, to use it internally. I'm wondering, so all the interactions that the user has, I mean, I suspect that when I do it on the ChatGPT, that OpenAI is somehow storing some of the chats that I have, or even getting feedback, because some of the times I say, this is not what I want is more on this direction. Are you also saving this kind of information on your side in order to improve the models, or?
As of now, we are not kind of tracking the history. So as we said, it's just in the thing, we are just experimenting, but saving the history is not integrated yet in our application. But yes, I think that will be also part of our roadmap. But the advantage is that we are storing
at least some examples to see how it behaves. But of course, we would like to have a proper database, not only to improve, because there I think it's much more effort, but to get a feeling for which purpose, for instance, people are using this internal tool.
Okay. Maybe one last question. So if I want to start doing this or implement this on my company today, should I start exactly where you started, or is there is there a new tool? I know that you talk about a new tool at the end. Is there a new tool that has already the whole package, or do I need to go step by step with all like you did?
Mm-hmm. So I think the approach we took is quite straightforward. Maybe here it seems a bit more complex, but if you look at the repo, it's really simple. It's like 2 files of code. One thing that we realized in the last few days is that maybe Gradio is not the best option. It has some, I would say, limitations. For instance, we found out that it forces you to have an online version of your dashboard, let's say, or your front end, which for us it's not nice. For instance, we are thinking about having some alternative like Streamlit, for instance. But apart from that, I would say this would be the way to go. If I start today, I think most of the things I will do the same.
Yeah, I would just add that this is more on the deployment side. But if you go to the beginning and to the tracking tools like DVC and MLFlow, I clearly see an advantage of using open source tools. And for example, MLFlow did this integration with Hugging Face early in the beginning, and the other platform that I just mentioned, Valohai, just did it more recently because it's a small company, it's not open source, and but on the other hand, not using open source tools but using paid tools also has another advantage. And one things is that Valohai offers all of the end-to-end MEL pipeline, but it's a paid service, so
You need to have money.
It's cost. Yes.
Okay, so thank you again, Filipa and Joana. Let's
Thank you.
A round of applause.
So we just want to make a quick thank you to our colleagues which are here, and mostly to the ones that worked in this project, because we presented it, but it's a team effort. So thank you to them. We are learning together.
Okay, I just. Okay, I just want to thank again Igor for giving us the space to enjoy. So I think we are done now. After this, we are going to meet. So who's in online? I'm sorry. For everyone that is here, yeah, let's just enjoy ourselves. There's some food in there. Yeah, that's it. Thank you all.